Hello guys, welcome back to Maths on African Motives. We are still on our revisions for mathematics of grade 10 level. Remember we had our introduction where we talked about exponents and we ended up at the law 5. So yeah, we just have a continuation, just like the previous case that we had, continuing now on 6 up to number 10. Then we can check some of the activities that we have that we can be able to attempt them. Also knowing your rules and so forth. Remember we talked about this, so we shall have a revision, which is basic for our grade 8 and 9, which is very, very important for you to start on. All right, so this is for our grade 10, but having a continuation from our grade 9 and 8 laws of exponents. Okay, remember that I want us to talk about this one, okay? We were talking about negative exponents before, and we ended up on a condition, guys, where I told you that if we are given x, let us take with the x being raised to a negative exponent like this. We say this will give us, we remove the exponent as 1 over x to the exponent of n. Okay? Meaning to say that if we multiply this by a certain term, right? If we multiply this by a certain term, a x to the exponent of negative n like this, we are going to have the constant that is multiplying on top, okay? So we're going to have this on top. So it's going to be a over this, as we know that it must be written down like this, x to the exponent of n, 1 over. So you're going to have this down, a being on top, which is the number that is multiplying here. So, and I told you that the reverse of this removing of the negative exponent is a condition where you have it in the denominator. If we have x to the exponent of negative n in the denominator like this, I said what you do is that you get rid of 1 and the negative. So your answer is going to be x to the exponent of n. You get rid of this 1 and the negative. So you're going to remain with x to the exponent of n. And I proved this, how exactly we got to this law. But remember, these are laws. You are supposed to follow the laws. You are supposed to know your laws, all right? Follow your laws. But if you want to understand, make sure that you watch the first video where I talked about the proving of these, some of the laws and rules that we have, okay? So if we now have a constant, a number that is multiplying, which is on top. So it's just going to be a number that is on top here, which is a over x to the exponent of negative n. So it is the same as what we have here. The a on top is the same a that was multiplying there. So it is the same thing, but this time us is going to have a positive. So we're going to have this as a, this 1 over this, it gives us a positive. So it's going to be x to the exponent of a positive n. So this is the one that we are explaining or that we are having here. So meaning to say, if I'm given an example like the one that I'm given here, I can simply apply that. All right. So let us check our example, how we are given. So we're given in this case 7 over y to the exponent of negative 6. All right. 7 over y to the exponent of a negative. So remember we say to remove a negative that will be in the denominator like this, we take it as a positive. So in actual sense, it was supposed to be y to the exponent of a 6. But there's a 7 that is multiplying also. So we're going to have this as 7y to the exponent of a 6. That is from this law that we are having here. All right, so what does this part actually means? If we are to use back our original laws, or if we are to take it back from where we understand our laws. All right, remember I talked about removing a negative, that is a number when it is being raised to a negative exponent like this, you take it as 1 over, to remove this is 1 over x to the exponent of n. Please don't confuse these negatives, guys. Please do not confuse this. So if I wanted to have this in a longer way, I could have done it this way, 7 over y to the exponent of negative 6 is the same as 7 over, okay, this here, y to the exponent of negative 6 that we see. If I want to use this law, I can use it because it states that a number raised to the exponent of a negative can be written as 1 over that number to the exponent, but of a positive now. So meaning to say, to remove this negative on y there, I'm going to have it as 1 over y to the exponent now of a positive exponent, which is positive 6. So it will be like this. That is, if you wanted to take it on a longer way. What does this part mean? Remember, whenever you have a division like this, you are dividing a whole number to a fraction. What do? You introduce a multiplication. From our grade 9, we said you're going to introduce a multiplication here. We tip the second fraction, so we're going to have interchange our second fraction. So this is going to be y to the exponent of 6 on top over 1. Okay? Remember, anything that is being divided by 1, it remains as it is. Okay? So that means you're going to have 7 times y to the exponent of 6, which is 7y to the exponent of 6, which is the same answer that we have here. So you see, the use of laws or the use of rules, as long as you understand what you are doing, you are going to have the same answer. So you just have to know your application of laws. All right, the same thing that we have here, if there's a number that we have now here, we're going to have that number also in the denominator. All right, if we are raising the whole of the bracket to the exponent of a negative n, the whole of it, it's going to be the whole of the bracket to the exponent of a positive. All right, that means whenever we are having a bracket, remember we talked about the issue of a bracket from our introduction. So it simply means if I'm saying 1 over ax to the exponent of a negative n, remember to remove a negative is going to be a positive, but this whole part, the whole of the bracket, is being affected by this negative. So we are going to also see the whole of the bracket being raised to the exponent of a positive, which is different from this part that we only had x, which was raised to the exponent of a negative, not a. So that's why we see a remains in the denominator, but the x to the exponent of n is written on top. That's the difference that we have here, because the whole of the bracket is affected by the negative. Let us consider a condition that we have. For an example, we are given 2 terms, that is 2x to the exponent of a negative 3, like this. Okay, what does this part mean? It means that we are going to have the bracket raised to a positive exponent. N was negative, but now it's a positive once you write it on top like that. So it is going to be 2x to the exponent of a positive exponent, which is 3. Here that we had as a negative, it is going to be written as a positive now. Once you are at this stage, we are now back to our brackets. Remember, from our brackets, we said if I have got AB being raised to the exponent of m, everything is going to be raised to the exponent of m. That is A to the exponent of m, B to the exponent of m. So what does it mean? It means I'm going to raise 2 to the exponent of 3, also x to the exponent of 3 from this law that we are having. So let us see what you're going to have. 2 when raised to the exponent of 3, and also x must be raised to the exponent of 3. And this means we're going to multiply, remember, to the exponent of 3 to the exponent of a number means you're going to multiply this base 3 times. That is n times if it is n, but if it is 3, we're going to multiply it 3 times. So if we multiply it to 3 times like this, we're going to obtain 2 times 2, which is 4, 4 times 2, which is 8. So that's 8x to the exponent of a 3. But like I said, the use of laws is in your hands. All right? The use of laws is in your hands. What am I trying to say here? Remember, if I do not want to apply, maybe I do not understand this, But I understand that law that I explained before, that if I have any term raised to the exponent of a negative, it is going to be 1 over that term to the exponent of n. All right. Considering that, we are going to see that here we are having a 1 over, which is same as we've got 1 over 2x to the exponent of -3. To remove that, it means 1 over 2x, like this. Take note, we want to remove this negative here. So it's going to be 1 over x to the x, which is this whole part raised to the exponent of a 3. But remembering this is, or this was from a single term that we had. So it means this fraction that we have is from one part of our number or our expression that we have. So meaning to say we are going to divide, all right, as usual, 1 over, we raise 1 over, okay, this one is going to be 1 over as we said. Then we are back now 2 to the exponent of 3, just like what I explained before, which is going to be 8, x to the exponent of 3, which is going to be x to the exponent of 3. Then, as I said, this is a single term. So you are now back to that part that we are dividing. 1 is dividing this fraction that we have. So what are we going to do if it is dividing this fraction? We are going to multiply and we interchange that fraction. So it's going to be 8x to the exponent of 3 over 1, which is same as 1 is same like this term as it is. And if you multiply by 1, there's nothing, it's just going to remain as it is. So as you can see, we are obtaining the same answer like this. But just check, guys, a lot of working was included there, which could have been reduced by using this law 7. This law 8 that we are talking about here. We could have used that direct, but if you do not understand it much, you understand this, go back to that understanding, use it to apply it, you're going to have the same answer. That is, it's not a problem at all as long you are using the laws to simplify whatever that you're simplifying. It must be according to the law. You are not forced to say, use this law. No, no, no. You are given a question to simplify. You simplify it the way that you understand it. Even if you go back to the traditional way of simplifying, if you understand that one, then use it. Okay? Number 9, a over b raised to the exponent of a negative. We saw that condition on our previous class, but it was a positive exponent. We saw that, let me put it this way before I explain this. We said a over b like this. When raised to the exponent of n, it means every term must be raised to the exponent of n, which is b to the exponent of n also. What is the difference with this one now? This time we are having a negative. A over b is now raised to an exponent of a negative exponent. We have a fraction here being raised to a negative. All right. What are we going to do? As we are used to this part of working with the positive, this is what we are used to, this part that we see here. We are used to say, if it is a positive that way, I'm just going to simplify direct. Okay, sorry for that, guys. If it is direct that way, I'm just going to simplify direct. This is what we are used to. So in order for me to do that, I have to interchange in order for me to remain with a positive exponent. I interchange what is inside here, and this becomes a positive. Take note. So I'm going to have it as b on top. I interchange, b is going to be on top, a goes down, so you just tip those two, so that will be b over a. And this changes to a positive. Once you have this, you can now go back to this to say whatever that I'm having here can be simplified in simplest form as b raised to the exponent of n, all right? And also a raised to the exponent of n, because we are used to working with positive exponents. So this will be how you simplify it when you are now simplifying your questions once you are at this stage. So what am I trying to say? Let's say we are given a over b being raised to the exponent of -2. It's difficult for us to work with the negative. Yes, I'm going to explain another way that you can use. If you understand it, you can use it also. So this simply means I'm going to change because I want to use this as a positive. So I'm going to interchange what is inside. So it's going to be b over a. I interchange that. The moment you interchange this, the sign changes also. All right? So it becomes a +2. So that means we are now raising everything to the exponent of 2. Remember, we are used to that here. I explained. So it's going to be b to the exponent of 2, a also to the exponent of 2. So that will be b squared over a squared. We are done. So if you check now, what it simply means is you can have it with a negative. This is the way they are explaining it on this pattern. It's a continuation from this. All right? It's a continuation that you simply have. But now I want you to consider before this that with the one that you explained before, remember we said we can remove a negative by writing as 1 over. So we can do this as, this is another way that we could have done it. Remember, to remove a negative, you can remove it as 1 over like this. We have removed the negative. Not to say you are changing the exponent. No, we are just removing this negative from the way that we know. Let me write it down. Remember, I said ba to the exponent of -n, it's 1 over a to the exponent of a positive. So if you want to write it this way, it means you're going to have 1 over. Then this part of a over b like this remains with a positive. It changes to a positive because it was a negative. So it changed to be a positive. So at the end, we are going to see we are going to have 1 over a to the exponent of 2, which is a squared over b squared. And in this case, we are dividing. It's 1 divided 2. So remember, our concept is that whenever you are dividing like this, you introduce a multiplication. So it's going to be this one, all right? This one times, you interchange the second fraction, not the first one, but the second fraction. So you're going to interchange this, what you have in the second fraction. So it will be b squared over a squared. Remember, this is the same as over 1. So you're going to multiply 1 times b squared, which is b squared, over 1 times a squared, which is a squared. So as we can see, we are obtaining the same answer as what we got from the previous way, where we just changed this using this law to say it is the same as you just interchange direct inside b over a, then this becomes a +2, which gave us b squared over a squared. So as you can see, you're obtaining the same answer, but this one, we are taking it from this law. So as long you are using your laws, guys, as long you are using your laws, you are going to have the same answer. So I want you to sit down with your laws, work with your laws, understand your laws, each and every law, each and every law, each and every law. From your mathematics grade 9, from your mathematics grade 8, revise those notes again. They are very, very useful. Okay, let's consider this. If I am given a negative exponent, which is m, and having b to the exponent of a -n, these ones, they are different, all right? This is m, this is n. We are going to have b as a positive on top, a as a positive down. All right, I hope you understand what I'm saying. A to the exponent is written as a negative. B is taken as a negative also. So what I simply do is that I want this to be positive. I also want this to be positive. So I take this on the other side because I'm going to have a fraction here there. So I'm going to take this on top there to be a positive. Okay, so it's going to be b to the exponent of n. I will take this down to be a positive. So this will be a to the exponent of positive m. I just hope it makes sense in your simplification. I just hope it makes sense. What it means is that x, when raised to a negative 3 and y is raised to a negative 4 like this, both are raised to negative exponents. So to simplify them, we can simply take this, the other side, to be a positive on top. It reverses what it was in the denominator. So you have to write it in the numerator as a positive. This one, it reverses what it was. It was a negative on the numerator. So it is going to be a positive in the denominator on the other side. So that will be x to the exponent of positive. We're done. All right. Someone is asking, why can't we use our normal laws? We can do that. Yes, we can. Okay, how? That's the question. Let's consider this. I want you to see this one, because this is a law, again, which can also be used in another way as long you are using your laws. All right, we understand that if I am given a negative exponent from the law that I explained, a when raised to a negative n, it becomes 1 over a to the exponent of n from our introduction. This is what I explained. So it means here I'm having x to the exponent of negative 3. So it is going to be written as 1 over, the moment I write 1 over, I remove the negative, it becomes a positive. So it's going to be x to the exponent of a 3. Okay, this is a single fraction. Over, we go on to y to the exponent of a negative 4. Again, we're going to apply the same thing. A negative to be removed is 1 over. So it's going to be 1 over y to the exponent of a 4, which is a positive. So what does this part mean? Remember what I said. Whenever you are dividing like this, say a term here is dividing another term there, what do? You introduce a multiplication on this part. So we are going to have 1 over x to the exponent of 3 multiplied to, the moment you introduce your multiplication here, you tip the second fraction, you're going to change it. So you're going to have y to the exponent of 4 over 1 like this. So what does this part mean? Remember from your multiplication, guys, what you do is that you can multiply as long it is the numerator to the numerator, the denominator to the denominator. So I can multiply this 1 times y to the exponent of 4 on the numerator. I'm going to have y to the exponent of 4 over x to the exponent of 3 times 1, which is going to give us x to the exponent of a 3. Guys, let us check. The answer here and the answer here are the same. But here we just used our law straightforward. Straightforward. Here, yes, we are using our laws, but we are using it, which is fine. But here we can use it direct to the answer, which is one and the same thing that you are going to obtain here. So that is the explanation of this law that we are seeing here. This is how we can have it. So what it simply means is that every term, as long it is written, let us take it this way. Okay, let us take it this way. I want us to check this example here. A to the exponent of -5, b to the exponent of -8 over c to the exponent of -6, and we've got d to the exponent of 2. Okay, I want you to see what is happening here this time. Our law states that if a negative exponent is there in the numerator, it can be written in the denominator as a positive. If it is in the denominator, you write it in the numerator as a positive. So what simply means is that you take down all these negative exponents that we see. They are what? On top. So you simply take them down as positives in the denominator. The one that is a negative in the denominator, you take it up to be a positive. So meaning to say a to the exponent of 5, a to the exponent of -5, we are going to take it down. B to the exponent of -8, we are going to take it down to the denominator to be a positive. Okay, so that is the scenario that you're going to do. So meaning to say, if we take these two down, what is going to remain on top is the C, which is remaining because we said it's carrying a negative. So we take it up to be written as a positive. All right, we have taken A down because it was a negative. So we take it down, it becomes a positive. We have taken B down to be a positive also. So it will be +8. What about D? It is carrying a positive already. So this one is going nowhere. It is just going to remain where it is because it is carrying a positive. Already it is having a positive. The reason why these had to change their positions is because we wanted them to be positive. But this one is already positive, this one. So there's nowhere it's going to be moved to. It remains as it is. All right. I just hope as we move on, guys, we shall have more questions. So also I explained about these other rules that we can be able to apply on our introduction of a number being raised to a negative n, a negative number to the exponent of n. And I said, if this is an even number, we are going to have our answer as a positive and raised to that even number, okay? If it is an odd number, we are going to have our answer as a negative. So make sure that you watch the video on the introduction so that you can be able to understand what I explained. So now we are going to have our simplification of these questions that we are given. So we shall quickly rush through our questions and see how we can be able to attempt them. Specifically, most of these areas, I want you guys to also work on them. Yeah, I'm just going to pick 1 or 2 questions, but on a case that you have a question that I did not attempt and still giving you a challenge, let me know on the comment section so that we can work on that question. On number 1, we are given to simplify 2p to the exponent of 3 being multiplied to 8p to the exponent of a 2. All right, if we go back to our laws that we talked about from the introduction, we talked about a condition whereby these bases are the same and you are multiplying in that case. And we said we're going to add our exponents, all right? Remember, if you're multiplying a to the exponent of m to a to the exponent of n, what you do is that you add your exponents. So in this case, for the numbers, just multiply 2 and 8, multiply them together. So 2 times 8, that is going to give us a 16. But when it comes to p now, because they are the same, so what you're going to do is that you are going to affect them, this part of p here, and also this part of p. So what you're going to do is that you add your exponent. So it's going to be p to the exponent of 3 plus 2 because we are multiplying. So you're going to add our exponents at the end. So this will be 16 p to the exponent of a 5. We're done. There's nothing that we can do at that stage. We can't simplify further. So this is what we call the laws, the application of the laws, all right? So like I said, you can do that in as much as you can. These are the questions that you're given, but I want us to focus on these laws that we actually or specifically mentioned on today and so forth and so forth. All right, and others that we are given that you can be able to relate. All right, then there are some questions of this nature whereby you'll be wondering, I want you to check what is happening on this question 6, all right? Just a little bit like what is happening here? 7 to the exponent of 2 plus 7 to the exponent of 2 plus 7. Here we are not having anything to do with our laws in this case to say we are talking about addition, subtraction, or what. We do not have a condition where we can apply the laws. So how do you attempt such typical questions? You work them separately, you work this separately, you work this separately, you work this separately, you add your terms as usual. There is no law that you're going to apply. So meaning to say 7 to the exponent of 2 means 7 times 7. You are multiplying it 2 times. So you're going to obtain 49 plus again 7 times 7, which is 49 plus a 7. So there is no law that you're going to apply. You simply add your numbers direct. You are not going to apply anything on that part. All right. So if you do not, if you're not good with your numbers, just use your calculator, because that one is the final stage of your calculation. So you can just add 49 plus 49 plus 7 like this. So this is going to give us 105. So that is 105 in that case. So this is how we can simply, we can simplify such typical questions. You just have to be careful on your simplification, how you are given the questions. Do you have a condition? Do you have the laws, or there are no laws? If there are no laws, then just apply the basic part that you know, then the rest leave it like that. All right, what about question 15? All right, this one can be also tempting to some. Let us just consider it also. On question 15, we are given those 3, all right? We've got the bigger bracket here, the major bracket, which is like the mother bracket, which is the outer bracket, this one. And 3, we've got the inner bracket inside, all right? So if we are to consider this, that we have got 3 like this, we've got a bracket, and this is 3, we've got a 2a squared b to the exponent of 3, and everything is being raised to the exponent of 2. If we are to consider this, we'll see that there is an exponent that we have here, and we said every exponent that we have must affect everything inside of the bracket. But in this case, as it affects, it is going to affect these two that are multiplying, the 3 and the bracket. All right, these terms are inside of the bracket. So first, consider these two that you can properly see. So this is how we can remove this bigger bracket, the outer bracket. The exponent outside, it affects everything inside. So it's going to be 3 to the exponent of 2. And the bracket also 2a squared b to the exponent of 3 like this, everything to the exponent of 2. So that you can properly see that, all right, here, what I'm seeing is that I'm back again to the same concept where this exponent is going to affect everything that I'm having inside of the bracket. So 2 is going to be affected to the exponent of 2, a to the exponent, be everything to the exponent of 2. All right, but on this part, I've already affected this. So there's nothing there. I'm just going to multiply. 3 squared means 3 times 3, 2 times. All right, so it's going to be 3 times 3, 2 times. All right, so meaning to say, we multiply 3 times 3, 2 times, going to be a 9. 3 times 3, that's a 9. Multiplied 2. On this part, like I said, you're going to raise everything to the exponent of 2. So this will be 2 to the exponent of 2. All right, a squared to the exponent of 2. So that means we're going to have a to the exponent of 2 to the exponent of 2. All right, b to the exponent of 3 also raised to the exponent of 2. All right, now what does this part mean? We can multiply. Remember that 2 to the exponent of 2 means 2 times 2, which is a 4. But that 4 is a number which can be multiplied to this 9. So you can multiply 4 and 9. What are we going to obtain if we multiply 4 and 9? So you can go back to our calculator. If you know the value, then you can write the answer. But if you do not know, multiply 4 times 9, you get an answer there, which is 36. So meaning to say, if you simplify these two here, you are going to obtain 36. So that is going to be 36. All right, here I'm back. An exponent and an exponent. What are we going to do? All right, if I have a being raised to the exponent of m and also raised to the exponent of n, how do I simplify this? I multiply the exponents together. So it's going to be a to the exponent of m times n. Exponent, exponent. So that's the scenario that you're going to apply here. 2 times 2, which is a 4. So that's a to the exponent of a 4. We move on to b, we do the same thing, an exponent and an exponent. So 3 times 2, which is 6. So that is what we are going to have at the end. So like I said, there are so many questions for you to consider. This is your revision from your mathematics grade 8 and 9. So I'm not going to talk much here. We're going to talk much when we are revising our question papers and revision. So what I want you to do is to just go through your revision from your grade 9 and 8. Like I said, use those notes that you were using on exponents just for a recap so that you can be able to get geared up to work on your exponents. It's not like you are working on something that is new. Even up to grade 12 mathematics, we shall see that it's just a continuation of this part. So if you understand it now in grade 10, you'll see that you have a green light in your grade 12, in your grade 11, everything shall be green. So let us try by all means to revise as much as we can.